is Boscoh Kimathi. My project is titled Resistance to Trypanocidal Drugs in Cattle Populations of Homa Bay County, Kenya. The aim of this project is to obtain data on the epidemiology of trypanosome resistance to trypanosides so that I inform policy on management of trypanosomiasis, build on existing knowledge on trypanosomiasis, and provide pointers to the management of the disease, and finally, to improve livestock productivity. The objectives of this study are two. Number one is to determine the point prevalence of animal trypanosomiasis, and this I mean the prevalence from the respective sampling sites that I will carry out my study. Number two is to establish the presence and level of resistance of trypanosomes to the most commonly used trypanosides. Those are dimenazine acetate and isometamedium chloride. My null hypotheses are two. Number one is that trypanosomiasis is not prevalent in the selected villages. And then number two is that no drug resistance exists against dimenazine acetate and isometamedium chloride. Now, these are the hypotheses that this study is going to refute. My alternative hypothesis is that trypanosomiasis is prevalent in the selected villages, and then there exists resistance against dimenazine acetate and isometamedium chloride. And my study is meant to confirm these two hypotheses. Study design. This study, before I conduct it, I will seek the approval from the Directorate of Veterinary Services in Kenya and the approval for the National Commission for Science, Technology and Innovation, NACOSTI, also from Kenya. The study area is in Lambwe Valley, southwest of Kenya, Homa Bay County. And now this area has a history of AV infestations by tsetse and a high prevalence of trypanosomiasis. And because of that, there has been a high usage of trypanosides in this area. Now, sampling, this will be a cross-sectional study, and the sampling size will be selected based on surveillance reports that I will get from Kenya tsetse and Trypanosomiasis Eradication Council, and it's a government of Kenya institution that is mandated to control tsetse and trypanosomiasis. Now, I will aim to collect 300 samples, and this will be based on an expected prevalence of 20% with a desired absolute precision of 5% at a confidence level of 95%. Now, to determine prevalence of trypanosomiasis, I will collect blood samples from ear veins of animals that we will sample, and then we'll use the Boscoh technique whereby the collected blood sample will be centrifuged and broken at the level of the Boscoh to obtain the Boscoh, which is white blood cells. And now these white blood cells will be subjected to microscopy. Now, in the microscopy, we're supposed to view motile trypanosomes. Now, the point prevalence will be determined by dividing the number of infections per sampling sites by the total number of animals that will be screened at that site. Now, data sheets of biological survey will be used to record data, and this will be data of animals biodata, data on the location, name of the location, geographical coordinates, and the animal species, animal breed, animal sex, and such like information. We also record data on PCV, the packed cell volume of animals, and also the infection status. And now this data will be collected in these data sheets. Resistance to isometamedium and dimenazine acetate will be determined in the following manner. Number one, animals that will test positives for trypanosomiasis will be divided into two groups for isometamedium and dimenazine acetate tests. And then we'll do block treatment, whereby on day one, the group A will be treated with 3.5 milligram per kilogram of dimenazine acetate, and group B will be treated with 0.5 milligram per kilogram body weight of isometamedium solution, the 2% solution. And then on day 14, we'll be monitoring them for relapse. So we'll use the Boscoh technique again to check if they are still infected or not. At the same time, we'll collect samples for molecular tests. And the molecular test that we are targeting to use is the polymerase chain reaction, restriction, fragment length polymorphism. On day 28, we'll again check the infection status of both groups of animals using the BCT technique, and then we'll also collect samples for PCR RFLP. Now, animals that will test positives or at this stage, what we'll do a swap for trypanosides, meaning that the animals that we treated with isometamedium will get dominance and switch rate treatment, and vice versa for those that got dominance and switch rate treatment at the start of the survey. On day 42, we'll still collect samples for PCR RFLP. At the same time, we'll use BCT technology for infection status of the animals. Now, the animals that will test positive at this stage is the confirmation that there exists a multi-drug resistance. Now, this data that we shall collect will be analyzed using mainly the R, RStudio, and Excel, and it will be presented in tables, graphs, and charts. Very much.